In this presentation, we will consider one special problem which is called pyramid of stars. We would like to print a pyramid of stars on the screen. Let's see how it looks like. If you want to print a pyramid of stars like this, which consists of 3 rows, then this is how it looks like, right? I simply ask user how many rows you want in your pyramid. The person might say 3, then I would print the pyramid with 3 rows. Similarly, if we want the pyramid of 10 rows, then this is how it looks like. And even if we want greater number of rows in our pyramid, then we can also do that. Like this. In this pyramid, there are 20 rows you can see. Isn't that beautiful? If you would like to print this pyramid on your own, then you might have to have a little understanding related to some topics. Basically, in order to print this pyramid, what you require is a basic understanding of matrix, what a matrix is all about, and you must also have a little common sense. So let's get started. Now as you can see, this is our 2 into 2 matrix, right? Here you are having 2 rows and 2 columns. That's why it is a 2 into 2 matrix. Suppose J represent columns and I represent rows. I would like to fill this matrix with stars using programming. Before that, I would like to ask you one question. How do we able to identify the location of this box? This box location is 1, 1. That means first row and first column. Similarly, this box location is first row, second column. This box location is second row, first column. And this box location is second row, second column. Isn't that so? After knowing the locations, we can use the programming technique to actually print stars in these boxes. How do we able to do that? Here is the code which will actually print stars in these boxes. For I equals to 1, I less than or equals to 2, I plus plus, and inside this for loop you're having another for loop, and in this for loop you're having a printf function which prints stars in these boxes. Now think about it, how this particular nested for loop structure works. When I is equals to 1, as the condition is satisfied, we come inside this for loop, right? And when we come inside this for loop, we find another for loop. As j is equals to 1 initially, we check the condition. As condition is satisfied, we simply print star. Suppose I represent rows and j represent columns. Therefore, when I is equals to 1 and when j equals to 1, we would be able to print star. After that, we come to this point, that means incrementing the value of j. As previously j is 1, after increment it becomes 2. We check the condition is 2 less than or equals to 2. As 2 is equals to 2, condition is satisfied. We come inside this for loop and print star. Now this is for I equals to 1, as I is still 1, and j equals to 2. That means first row and second column. That means at this particular location we would be able to print star. Now we again increment the value of j after printing star. Now j becomes 3. As 3 is not less than or equals to 2, therefore we come outside of this for loop, right? Why do we want 2 here? Because here are only 2 columns, right? After completion of this for loop, we come to this point, that means incrementing the value of I. Previously I was 1. After increment it becomes 2. Now 2 is equals to 2, condition is satisfied. We again come inside this for loop. Again j is initialized to 1. And again the condition is satisfied and we simply print star. But at which location? I is 2 and j is 1. That means second row and first column. That means star is printed over here. After printing this star, we increment the value of j. J now becomes 2 and again the condition is satisfied. We again print star, but for this time we are printing it for I equals to 2 and j equals to 2. That means at this particular location. Now you can easily see how this nested for loop structure is mimicking the behavior of a matrix, right? This represents number of rows and this represents the number of columns. And in the row wise manner, we would be able to print stars on the screen. Similarly, for a 4 into 4 matrix, we would be able to print stars using again this nested for loop structure. But the only difference lies is that here you're having 4 into 4 matrix. Therefore, the number of rows should be changed to 4 and number of columns should also be changed to 4. And the rest of the thing is exactly the same. Now I hope you understand how do we able to print stars on the matrix using nested for loop structure. Now it's high time to get into the problem. See this particular structure. As you can clearly see, this is a pyramid, right? We can easily represent this pyramid using matrix. How can we do that? Here you can see I'm representing this pyramid using a 4 into 7 matrix. There are 4 rows and 7 columns, right? Similarly, we would be able to represent this pyramid also with the help of a matrix, which consists of 3 rows and 5 columns. Our first target is to know when you are having n number of rows, then how many number of columns you actually require. Obviously, for different number of rows, you are having different number of columns. Like in this case, you are having 3 rows and 5 columns. In this case, you are having 4 rows and 7 columns. Therefore, it is a requirement that if we want to represent a pyramid like this, we first need to know how many number of columns we require corresponding to the number of rows we have. If we are having 3 rows, then we require 5 columns, as you can clearly see here. If we are having 4 rows, then we require 7 columns. If we are having 5 rows, then we require 9 columns. You can easily see this. And if we have 6 rows, then we require 11 columns. You can easily see the pattern here. If you're having n number of rows, then we can clearly say that we require 2n minus 1 columns. So we can easily obtain the number of columns by using this formula, right? Therefore, our first task is finished. That means for our nested for loop structure, we require n number of rows and 2n minus 1 number of columns, right? Now, let's move on to our next task. As after completion of this task, that how many number of columns we require when we have n number of rows, we need to know how do we able to print stars like this in this matrix. Remember that we do not have to fill all these boxes with stars. We just have to fill few of them so that we would be able to obtain this pattern, right? Let's try to understand how do we able to print this pattern. As you can see, in the first row only 1 star is printed, and that too in the 4th column. In the second row 3 stars are printed from second row 3rd column to second row 5th column. Similarly, 5 stars are printed from 3rd row 2nd column to 3rd row 6th column. And similarly 7 stars are printed from 4th row 1st column to 4th row 7th column. If you observe this carefully, this 4 is nothing but n only. Isn't that so? As you're having n number of rows at a particular instance of time, here you are having 4 rows. Therefore, we can say that this 4 is nothing but n only, right? Similarly, we can say that this is n minus 1 and this is n plus 1. This is n minus 2 and this is n plus 2. Similarly, this is n minus 3 and this is n plus 3. Now, let's try to understand what is happening here. When you are in the second row, you are printing stars from n minus 1 to n plus 1, right? Can we write this n minus 1 as n minus 2 minus 1? As 2 minus 1 is 1, therefore we would be able to obtain 1 here. Why I'm writing 2? To actually relate this to the second row. This is n minus 2 minus 1 and this is n plus 2 minus 1. So we can say that we are printing stars from n minus 2 minus 1 to n plus 2 minus 1. Similarly, for the third row, we can say that we are printing stars from n minus 3 minus 1 to n plus 3 minus 1. Similarly, we can say that for the fourth row, we are printing stars from n minus 4 minus 1 to n plus 4 minus 1, right? And also for the first row, we are printing stars from n minus 1 minus 1 to n plus 1 minus 1, which is equals to n only. So what we are actually obtaining from this particular observation? When j is greater than or equals to n minus I minus 1 and j is less than or equals to n plus I minus 1, then only we should print star, otherwise we simply print a blank space. Here I represents the row. Suppose you are in the second row, then you should print stars from n minus 1 to n plus 1, right? This is the idea we need to adopt. As this is the correct code, we can add this in our actual code. Inside this nested for loop structure, now you can add this whole code snippet and it will definitely print the pyramid as needed. Let's try to execute the code and see whether we would be able to get the pyramid or not. This is the same code that we had seen previously. The only change is that I have declared 3 variables n, I and j. After that, we have a printf function that simply prints how many rows you want in your pyramid. And after that, we simply accept the input, that is our number of rows, and then the same code is used to print the pyramid according to the number of rows. Let's see what could be the output. It asks us to how many rows you want in your pyramid. Let's say I entered 10 and hit enter. As you can see, a pyramid is printed on the screen with 10 rows. I hope you got it. Thank you for watching.